Welcome to Action Research. Today's topic is bridging the gap between teaching and research in college classroom. Now, we will discuss some important aspects of action research. Definition, type, step, purpose of action research. Key characteristic of action research. Action research in teaching. How to conduct an action research. Examples of educational action research. How to evaluate, publish your research project. Action research starts from identifying the problem, developing a plan, carrying out your plan, collecting and analyzing your data, reflecting and sharing your finding outcome. Action research includes cycles of planning, acting, observing, reflecting. Each research project could have several cycles. There are differences between traditional research and action research. Traditional research is conducted by university professors or scholars in environment where variables can be controlled, using rigorous research design to show cause-effect relationship, to obtain knowledge that is generalizable, and to develop, test educational theory. On the other hand, action research is conducted by the educationists. In schools and classrooms, changes are made during the study to obtain knowledge that can be applied directly to the local classroom situation. Be aware, action research is not linear, conclusive, problem-solving, why we do certain things, generalizing to larger populations, the implementation of predetermined answer. Action research is cyclical, practical, and relevant, a process that improves education through change, explores, discovers, and seeks to find creative solutions, improve instructional practice by observing, revising, and reflecting. Action research in education. According to Mills 2000, action research is systematic inquiry done by educators to gather information about and subsequently improve the ways their particular educational setting operates, how they teach, and how well their students learn. How did action research develop? In 1970, action research was used for faculty development activity. In 1980, action research became college administrative focus. In 1990, action research was used for professional inquiry by faculty, such as self-development. Since 2000, action research became part of faculty and college inquiries. For example, faculty initiate research study. Key characteristics of action research include collaboration, plan of action, practical focus, dynamic process, sharing research, study of educator researcher's own practice. 3 types of action research. Number 1, individual faculty research. Individual faculty go through the process of a research project. Number 2, collaborative action research. Some faculty conducting a research project together. Number 3, college-wide action research. Research process involves the entire faculty in conjunction with a college consortium. There are three common action research models. Number one, technical action research. Number two, practical action research. Number three, emancipatory action research. Technical action research. The main researcher identifies the action research problem and proposes an intervention. The practitioner involved in the implementation of any interventions. Practical action research. The researcher and the practitioner identify the research problem together and discuss underlying cause and possible interventions. Emancipatory action research. Practitioners work together as a group and collectively identify problems and possible solutions. Participants will usually emerge with a new idea or theory of society. When to use action research? Need to improve teaching and learning. Have an educational problem to solve. Want to reflect on your own practice. Wish to address college-wide problems. There are many ways to collect data for action research, such as taking field notes, using analytic memory, using or taking photography, observing individual or groups, using audio, video tape recording, distributing survey or questionnaires, using structured, semi-structured interview. Now, we'll look at an example of practical action research. The title is Using Interactive Multimedia to Support Learning Geometry. The current lecture style is using transparency and projector. But there is a problem. The lesson is not effective. No visual simulation. The research question is, will interactive multimedia support learning geometry? This study wants to find out what happened to teaching and learning from using transparency and projector to implementing interactive software. This study has two cycles. Cycle 1, question. Investigate the value of multimedia for learning math. Plan. Show math video during lecture. Observe. Students' preference for math lesson with video. Reflect. Evaluate learning outcome and students' feedback. Cycle 2. Review the question. Review the result and investigate online GeoGebra, interactive learning tool. Plan. Integrate GeoGebra into the existing programs. Observe students' reaction toward GeoGebra. Reflect. Results indicate positive learning experience. Review. Cycle 1. Question. Investigate the value of multimedia in supporting teaching and learning for geometry classes. Plan. Use math video to stimulate students' interest and to investigate students' learning attitude and learning outcome in response to such technology integration. Act. A series of geometry video was watched during lecture over a one-semester period. Observe. Feedback was obtained from students about their preference for learning and watching math videos. The effect on students' learning was also evaluated. Reflect. Most students prefer to learn in a lecturing environment accompanied by videos. that help them digest information, and they were able to visualize some concept in a more vivid manner. However, some students expressed that they would like to have an interactive learning experience. Cycle 2. Review the question. From a literature review, it is difficult to visualize how the mathematics work. Investigate online interactive simulation, GeoGebra, that may help students learn geometry. Plan. The GeoGebra was integrated over a one-semester period to create interactive mathematical analysis lesson. Act. Students were assigned tasks in different questions, focused on how to apply geometry concepts in problem solving. Observe. Collect both objective and subjective data before final exam by means of questionnaire survey and interviews. Reflect. Results indicate that the GeoGebra had increased students' incentive to learn and interest in geometry. Visualize related concepts and how they affect each other. Action Research Guidelines. Consistent. The research question should be answered at some point later in the paper. Connecting to the literature. Link to other research that's already been done on this study. Collecting data and findings. Identify the data collection tools and state the finding. Logical reflection. A. The objective you held at the beginning of the project. B. The thought and reaction you had during the process of completing your study. C. How your original goal may have modified as a result of completing this project. Clear implication. Describe next step you want to take, additional research that need to be done, and how your findings related to the education community at large. Checklist for action research. Clearly address the research problem. Collect sufficient data. Lead to positive change. Plan of action advance logically. Enhance the life of participants. Report to audience who might use the information. Thank you for watching. I wish you a very successful research journey.